Today we are going to draw ray diagram for the image formed by convex lens. Look at this. This is a convex lens which is thicker in the middle and thinner at the edge. And when an object is placed in front of it, then it forms its image. And it forms different types of image in different places and different nature of image according to the distance of object from the lens. Now, after a lot of practical observations, what is found? Convex lens forms 6 different types of images, and when the object is taken at infinity, then one type of image. When object is taken at taken in from b1 to f, then second condition, another type of image. And third condition, when object is at 2f, another type of image. When object lies between f and 2f, another type of image. When object lies at focus, next type of image. And when object lies between focus and optical center, another type of image. This way, a convex lens forms 6 different types of images according to the position of the object from convex lens. Now we are going to draw all these images with the help of few rules. I told you these rules in previous class also. We are using 2 rules. Look at this. First rule says that when a ray of light comes parallel to the principal axis of a convex lens, it passes through focus. When a ray of light comes parallel to the principal axis of the convex lens, it passes through focus. We are using this rule to draw the ray diagram. Another, look at this second one. When a ray passes through the optical center, it passes without deviation, whether it comes from lower side or upper side, doesn't make any difference. Using these 2 rules, we are going to draw all these 6 different diagrams which a convex lens forms. Now let's start with first one. When object lies at infinity, what it means? Object is if at infinity, then we cannot show object in this paper. Now we have to imagine that these 2 rays of light are coming from the object. This is one ray of light, and this is, let's see, another ray of light, and this is coming from the object, and we are taking them parallel and parallel to the principal axis also. These 2 rays are, let's say, coming from the object which is at infinity, and they are parallel to the principal axis. That's why they passes through focus. Both of them passes through focus like this. Now what it means? Whenever we have to draw ray diagram or whenever we have to form image, then at first we'll draw 2 rays from the object, and after the refraction or reflection, where they meet, image forms at that place. Here 2 rays are taken and they are meeting at this point, and that's why image forms at this point. And this is real image. Why real? Because really refracted rays are intersected at this point and image is formed. That's why this is real image. And this is inverted image. Real image is always inverted. At this time we are not able to see this image, but in another diagram we will be able to see the inverted image directly. And this image, real, inverted, real and inverted image forms at focus. Where it forms? At focus. Focus. And it is so small that we are not now able to see it. It is point like, that's why it is highly diminished. This is highly diminished image. Now if we have to write the nature of image formed by the convex lens when object lies at infinity, then we can write real, inverted and highly diminished image forms at focus. Okay, this is one solution. Now let's talk about second one. When object is taken b1 to f, I mean to say when object is placed b1 to f, then what type of image forms? Look at this. Object is b1 to f, it is here, and we can draw ray diagram from this object this way. A ray of light coming from the head of the object if taken parallel to the principal axis, then what happens? It passes through focus according to rule. We are using those two rules. Just before this I told you. Another ray of light which is passing through the optical center passes straight without bending. Both the rays of light are meeting at a point behind the lens. Really they are intersected at this point. That's why image forms at this place. Since the ray of light coming from the head gone down, that's why here they are intersected at this point. That's why it goes down. And what type of image is formed here? This image is real. Why real? Really refracted rays are meeting at a point. That's why real image. Real image. And it is inverted. Real and inverted image, and it is diminished also. And where it forms between what? Between F and 2F. Look at this. This is our conclusion. When object lies beyond 2F, then a real and inverted image, real, inverted and diminished image forms between focus and 2F behind the lens. This is second case. Now I'm going to draw third case. Look at this. When object lies at focus. If object is at focus, then one of the ray of light we are taking parallel to the principal axis according to the rule, and we know that it passes through focus. It passes through focus. And another ray of light which is passing through the optical center passes straight without deviation, and it is intersected at this point, and image forms at this point. Since the light coming from head is intersected at this point, that's why head goes down, and this is the image. See, before refraction, after refraction, we have to take arrow mark also. This image is, again, we found real image. Why real? Because really the refracted rays are intersected and image is formed. This is real image, and it is of same size also. It is inverted. It is of same size and forms at where? At 2F behind the lens. That's why when object is at 2F, then a real and inverted image of same size forms behind the lens at 2F. This way we finish the third one. Now let's talk about fourth one. When object lies between focus and 2F. This is the object. Now we are using the same two rules what I told you just before this diagram. This is one ray of light coming parallel to the principal axis. We have to pass it through focus. It passes through focus according to rule. It passes through focus according to rule. And another ray of light which is passing through optical center passes without deviation. This way. So they are intersected at this point. That's why image forms at this point. Since the ray of light coming from the head is intersected at this point, that's why head goes down. We have to draw this way. Head goes down. Now what type of image is formed? Again, our image is what? Real. This image is real. And it is inverted. And it is magnified. It is bigger than the object. And where it formed? Beyond 2F behind the lens. It forms beyond 2F behind the lens. This is fourth condition. Now I'm doing fifth condition. Look at this. When object is at focus. Now what happens when object is at focus? One ray of light we have to draw parallel to the principal axis, which passes through focus. We know this according to our rule. And another ray of light coming through this optical center passes straight without deviation. Look at this. Now what is seen? This is the ray of light passing through focus. This is another ray of light. It is passing straight, and both of them are not intersecting in behind the lens. Why they are not intersecting? They appears to be parallel with each other. Usually they appears to be parallel with each other, but exactly they are not parallel to each other. When they are drawn for long distance, then they will meet at infinity. That's why image forms at infinity. And this image is also real, because really they meet at infinity. Real. And real image is inverted. It is inverted. And when they are produced to very long distance, and this principal axis is also produced to very long distance, then they will meet with each other. I mean to say, these two meet with each other. That's why image is highly magnified. Highly magnified. And it forms at infinity. Look at this. This is the solution of fifth diagram. Now I'm talking about last one, sixth diagram. When object lies between focus and optical center. Look at this. Object is previously drawn. Now I'm going to draw the ray diagram. The rays according to the rule. This is the ray parallel to the principal axis. It passes through focus. It passes through focus. Another ray of light passing through the optical center passes straight without any deviation. Look at this. This passes straight. Now there is no chance of intersection of these two rays. That's why we have to produce them in opposite direction. That's why I'm producing this in opposite direction. Look at this. And we have to produce the second ray also in the opposite direction. And where they meet, image forms at that place. Look at this. Image forms at this place. Since the ray coming from the head is meeting at this point, that's why head goes up. And this image is virtual image, because really light rays are not reaching up to the image. That's why image is virtual. So virtual image is represented by dot line. This way the image is for the first time virtual, and it is erect, and it is magnified, which forms in front of the lens. This way we can draw a ray diagram of this convex lens. There are 6 conditions. All these 6 conditions, what type of image forms we have drawn just now. This much for today.